Dear Father in heaven, we're thankful for this day that we have to be together and thankful that our schedules can align so that we can work together and try to progress through this class and continue to learn more throughout the semester. We pray now that as we discuss new concepts and take our quiz that we may be able to do well and clarify the different aspects of this week's lesson that may be unclear to us now, and that we can solidify it in our mind. We're thankful for the resources we have with modern technology as well as those offerings of BYU Idaho. We're also thankful for the opportunity to study more flexibly online. We're thankful for the gospel and pray that the rest of our day may go well. And these things we pray in the name of Jesus Christ.
Amen.
Do you have any questions about the content this week?
I don't think so.
I don't have much to up yet, but I'm going to start.
Okay.
You already have it up.
Yeah, I just put it on.
See, I was like waiting for an email with the assignment, and I was just like, no, please.
Wait, for the collected data one?
No, the one that you sent last night.
Oh, okay.
The data.
Oh, yeah. No, I thought it.
You sent it, I think, last night, like right before my sister, or was it last night? Maybe I just didn't like see it.
Collect and describe the data, right? That one.
Oh yeah, that's why I didn't see it. I don't know why I missed it, but
Oh, okay. Yeah.
this weekend is kind of crazy. We like play peek with another person in our ward, and they were like, "Oh, I'm sick on Saturday," so we had to like on top of all the other stuff we were doing, we had to spend our lesson together.
Mm-hmm. It's cool.
That's nice feeling that we just do together. Yeah. Yeah, it's been good. Let's start with question 3. The true linear regression equation is y equals no plus beta 1 x, where beta null and beta 1 are unknown. What are the null and alternative hypotheses for beta 1? Beta 1 is like the slope, right?
Yeah.
So the null would just be 0, and then the alternative would be greater than 0, so it'd be the second one.
Okay. A residual is the difference between B0 and B1, depends on the independent variable, is the difference between the observed value and the value predicted by the regression line, is what is left over after doing a linear regression. I think it's that third one, the difference between.
Cool. Question 5. A plot of residuals supports using linear regression when the residuals look normally distributed, the residuals are all positive, you see a megaphone shape in the residuals, and you see a pattern in the residuals. Well, I want to say they look normally distributed, but that seems like the same as the megaphone kind of.
Yeah, like they'd have a pattern or something.
Yeah. Well, they mentioned specifically that megaphone shape, kind of like the bell shape, but like, yeah, I'm just gonna go with normally distributed.
Okay. Is it all right if I go with the positive ones, and then at the end we can see which one's right?
Yeah.
Okay.
Yeah.
All right, for question 6, we got to download the math self-efficacy. And it says use the confidence variable as explanatory variable and the score variable as a response variable. For question 6, it says compute the residuals for the data using software. What statement best describes the residuals? Okay. Okay, so I put the data in the software, and now we got to pick from the residuals are between -40 and 25. The residuals form a linear pattern, and the residuals are all negative. Okay. Shoot. I don't know why mine's not letting me copy and paste the residuals section. Oh, does it? But then it doesn't. Paste special.
What are you copying it into?
Okay, there it goes. So for question 6, I would say the residuals form a linear pattern.
Based on the Q2 plot for these residuals, what can you say about the residuals are clearly not normal? The residuals are fairly normal. The residuals look right skewed. Um, so I would say they are fairly normal. Although I'm a little foggy with these linear um, residuals about how to tell. Because I know with like the bell shape, it's kind of easier to tell how it's right skewed, but with these,
Yeah, no, as long as they're following that line on the QQ plot, if they're right on the
yeah,
line close to it, then they're pretty normal. Um,
yeah. But is it like how is it right skewed? Is that just depending on where the curve goes? If it curves,
I don't know. I don't know about the right skewed, but I know that they've taught us if they're normal or not.
yeah,
I think that might just be
yeah.
a question.
Okay, cool.
You want to just go fairly normal with that one.
Yeah, yeah.
Okay. For question 8, use software to create scatter plot of the data. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. There is a linear relationship between x and y. The variance of the error term is constant for all values of x. The residuals are normally distributed. The x values are measured without error, and the observations are independent. Okay, let's see. Okay, so for question 8, I know that the first one is can be checked off because the significant value is close to 0, so there would be a linear relationship. And the residuals are normally distributed because we took the residual numbers and put them on a QQ plot, and they were close to the line, so they are normally distributed. So that middle one's checked off, but I'm a little iffy on the other 3.
Yeah, I was gonna say I had kind of a confusion with the x values and measured without error. I'm trying to find how we find that. If we even have this full graph. So x's are known constants. Cannot be checked directly. X's should be measured accurately and precisely. So the x values being measured without error, I don't know that we can actually check that one please. So we can't check check it directly.
Yeah.
Since observations are independent. 6 million values and then the y's is nothing without the other points.
Yeah, well, the observations can't be independent, right? Because they have to be one's the what do you call it? The explanatory, and the other is the response. So they have to depend on each other. So that last one.
Yeah, but each individual observation.
Oh, I see.
Really, like that. That's kind of where design the study phase. Is then like this observation again. It says for the normal error term that it's determined by the points on the QQ plot being close to the line. So I think that we can say it's constant. So I think we can check off the first 3 and then the last 3.
Okay.
We can.
All right. We'll go with that.
So, question 9. What is the estimate for the slope? We have 0.042.
You got 0.042.
Yeah. Did you get something else?
Yeah, I got something different. I got 12.695.
Did you put which one did you put for the response variable?
I put for the response. I put the score for the response variable. Is that what you put as well?
Yeah. No. That explains it. It's because the slope sound. So I guess let me just do the graphic. Was it, you said 12.695.
Yeah, that's what I got. All right. For question 10, it says construct a 95% confidence interval for B1 input. Your answers for the lower input, for the lower bound and the upper bound. The lower bound. So this is asking us to use 12.695, right, as the X value, and then use and do a 95% confidence interval.
Wait, what? You're saying use the slope as the,
I think so. I don't know because it doesn't give us any X values in here. You know, and it doesn't say anything.
you still have the
Yeah.
thing like where it says this, the y-intercept and this, it already has, like at the top, you have set the confidence interval, those values to the right of the slope and the y-intercept.
Oh, I see. I thought,
So,
would it be that was 10.674?
so B1 is slope, right?
Yeah.
Yeah, yeah. So that's what we do to the 10.674.
Oh, okay.
And for the upper bound, 14.715.
Okay, for question 12, based on the evidence and using level of significance A equals 0.05, what decision would you make regarding the hypothesis test for B1? So p-value is going to be close to 0. So we're gonna reject the null because p-value is less than a. So the third one.
Yep. Question 13. For a hypothesis test for slope, if you reject the null hypothesis, what does it mean? There is insufficient evidence to conclude that the slope of the regression line is 0. There is sufficient evidence to conclude that the slope of the regression line is 0. There is insufficient evidence to conclude that the slope of the regression line is not 0. And there is sufficient evidence to conclude that the slope of the regression line is not 0. We'll go with that last one, because that's the alternative.
All right. That's the question 14. You have to download that Excel file. And then they ask, what the dependent variable is. So this is the one where they had to measure the head first, right? And then based off the head, they went and found the body length.
Yeah.
Oh yeah, yeah. It even says it on the thing. So the dependent variable is body length.
Okay. Information. Let's construct a 95% confidence interval for B1. Input your answers for the margin of error, lower bound and upper bound. Okay, Tony. This be the one in the J column near the top, in the model center, the standard area of the estimate.
Maybe. I don't remember. And I've been looking in the book to see if I could find anything. You want to just choose that one?
I want to find first. Yeah, let's just use that.
All right.
10.801.
Okay, for question 16, it says input the lower bound. And we're going to use B1. So I put 7.218.
Input the upper bound 8.103.
Okay, and for question 18, it says based on the lower and upper bound from the last two problems, what can you say about B1? That we are 95% confident the confidence interval will contain the true values of B1. There's a 95% chance confidence interval will contain the true value of B1. There isn't sufficient evidence to reject the null hypothesis. I would go with the first one, 95% confident. Okay.
Cool. Were you going to try a different answer before you submit for question 15? Were you going to try anything different, or were you also putting the 10.801?
Let me turn it in first and see what we could get.
Okay.
You know what? Okay, yeah, that one's not it. 10.801 is not it. Yeah.
So I'm thinking that we use the upper and lower bounds to determine it. But I forget if we get an average between the two, or if we just get the difference. Or is it like the average of the difference? Do you remember?
I don't. You know, I honestly don't remember doing a margin of error for this lesson for these what do you call them? Bivariate.
Yeah.
You know?
But I mean, like, it should be the same for a confidence interval. I just wasn't sure if we were working with the slope or the other one.
Mm-hmm. I think I still have notes on that. But just so you know, don't turn yours in yet, because for question, where is it? Okay, for question number 6, I think we both put the same answer, and that one's wrong. The residuals form a linear pattern. That one is false. I think it might be that first one, between -40 and 25.
Okay, that's what I was thinking, and then you like checked it, so I was like, well,
yeah, because
I guess it could be that one too.
Because the lowest one was like -38, and then the highest one was like 23, and I was like, I guess that's close, but I don't know.
Yeah.
Okay. Let's see.
Yeah, I'm trying to find that.
Okay, I have this formula. That's where you take the highest confidence interval and you subtract the lowest one, and then you divide by 2, and that should give you the margin of error.
All right, so it's the difference divided by 2. Cool.
Okay. Hopefully that's it.
I mean, because like I remember we've gotten it wrong a couple of times in a couple of quizzes, and we've gotten it right in a couple.
Mm.
Remembered like which ones were wrong and which ones were right.
Yeah. Oh, and for question 3, that one should be the third one. I think you chose the greater one.
Yeah. That it should be the third one.
Yeah, where the null is equals to, but the alternative is not equals to. Yeah.
Okay. The only thing that I got confused with there was the fact that like we haven't really worked with negative slope in any of these yet.
Yeah.
That's the thing. So I have something for section 15.
All right.
I think it's 0.443.
0.443.
Yeah.
Okay.
And then were there any others I need to change up as well?
No, I think that should be it.
Yeah. Yep. You're all right.
Nice. Okay, cool.
You remember that from now on, the margin of error.
Yeah, seriously. I always get mixed up.
Awesome.
I always get a brain fart for those.
Yeah. I also don't know why they do like if we're just gonna use the scores other than the confidence interval for the slope, like why do they even have a calculated one for the y-intercept, you know?
Yeah.
Okay,
It's because they don't want to do all the work for us.
Yeah. Well, I like before we really started, like relying heavily on the formulas that were in the spreadsheets and stuff.
Mm-hmm.
I actually thought about like making my own and just like taking notes on it, and then I like we started using them more, and I was like, okay, I guess I'll just use these. Because like they don't have every formula, but you could still input like the formula, and all you need to do is input the values in that spot and like result it.
That's true. Probably do that from other math classes that I'll take later, but I like having them made already for me. Super nice.
Yeah, for sure.
All right.
All right, so I guess I'll see you on Thursday.
Yeah, I'll see you on Thursday.
Cool. Good luck soon.
All right. See ya.